So today we're doing lesson 27, solving percent problems. We only have 3 more lessons before we're done with our ratios, percents, and rates unit. So our I can statement is I can solve percent problems using whole, parts, and percents by labeling each component. So remember, when I'm working with percents, I'm making a whole. What is that whole? That whole, when I'm working with percents, will always be 100. I'm working with parts, and I'm working with percents. So that percent is going to be the number that's right on top of my 100, and the part is going to be when I have an equivalent fraction, it's going to be that numerator over denominator. So what I'm trying to do is I'm trying to take a fraction, a part over whole, I'm trying to convert it so its denominator is 100. So let's look at our first reminder from yesterday. So this is what we just went over. When I have a part over a whole, I'm trying to convert that so its denominator is 100. So for example, if I have this number, this was from yesterday's problem, 5 girls are 7th graders out of 25 total on the soccer team. What's the percent? Well, here my part is what? My part is this 5. What is my whole? The whole is 25. And what am I trying to do? Well, with percents, I'm always trying to find an equivalent ratio with 100 as denominator. So how do I get from 25 to 100? Easy, I multiply by 4, and I multiply by 4. So if I'm unsure of that, this setup right here, I can always make that ratio table, where it's my part over whole, so part is 5, whole is 25, and what number am I always trying to get this whole to equal for 2%? I'm always trying to get it to equal 100. So how do I get from 25 to 100? Multiplied by 4. How do I get from 5 to whatever this number is? I do the same thing that I did on the right side. I multiply by 4. So I'm left with 20%. Remember, when I'm making a ratio table, there's several ways to write ratios. One is 20 to 100, 20 to 100, or as that fraction, 20 to 100. And we see this way of writing a ratio is the exact same thing as this way over here. Alright, so let's look at this part. I'm going to write the words percent, whole, part under each problem to show which piece you are solving for. So it looks like that each forgot that H. So let's look right here. Here's my first one. 60% of 300 equals blank. So I need to figure out what is it that I'm looking for right here. Well, I know it's not my percent because my percent is right here. 60% of 300. Well, that means this is my whole. I'm finding a percent of a number. So if I'm looking for the percent of something, this of is what my whole is. So what am I left with? I'm left with this part. So I'm looking for part of 300. So how do I find 60% of 300? Well, there's several ways. I'm going to use this model right here. So I'm going to just copy what I have down, 60% of 300. And I'm just going to fill in this little equation that we've been working with. So I know what my percent is. My percent is at 60. So I'm going to fill that 60 in right here. If you're not sure, I'll highlight it. That 60 is my percent. So I'm just filling in the same spot. That 100 will always stay the same. And now I'm going to look for these missing parts. Part over whole. Well, this was my percent. What was this 300? That 300 is my whole. Remember, if I'm looking for 60% of 300, this of means I'm looking for a whole of something. So now I'm left with this problem. How do I get from here to here? If I can figure that out, then I can do the exact same thing to my numerator. So how do I get from 100 to 300? That's easy. I multiply by 3. So what do I need to do to my numerator? The same thing. I multiply by 3. I get 180. If I'm not sure, I can also fill in my chart on the right side. My percent is 60. My whole is at 100. And now it's my equivalent fraction. I'm looking for that 300 because it's also a whole. I'm looking for this mystery number right here. So how do I get from 100 to 300? Times 3. So I need to do the same thing to the opposite side. And we see 3 times 106, or 3 times 60 is 180. And we see my answers are the same. So I can answer this first part. What is 60% of 300? Well, that is 180. And I can just check in my brain, does it make sense? Well, 50% of 300 would be half, so that it should be slightly more than half, which it is. And look at that, our answers match up. Alright, now let's try this one. 60% of blank equals 300. So notice how this 300 now got shifted over here. So I'm looking for 60% of what? So let's start out by labeling it first. So my first part is 60%. Well, this is my percent. So I know my percent. This of, I'm looking for what? When I say 60% of something, I'm looking for part of the whole. So I'm looking for my whole, but I don't know it. However, I do know what my part is. My part is however much is going to be a partial amount. So what do I need to do? I need to find out what my whole is. So I'm looking for my whole in this example. So now I'm going to go back to this portion. I'm going to reset my page, and I'm just going to copy what I have. 60% of blank equals 300. And I'm just going to copy the labels. This was my percent. This was my whole. And this was my what? This was my part. So now I can just fill it into my ratio table. Well, my percent is 60. Actually, I'll just write underneath. My percent is 60 out of 100. Since it's a percent, that means my numbers are just going to stay 100 for its whole amount. Now I'm looking for what? 300. Is that 300 a part or a whole? It's a part, so that means it's going to go on my part side of my ratio table. So now I'm going to ask myself, how do I get from 60 to 300? Well, I multiply by 5. So what do I need to do to the opposite side? The exact same thing. I multiply by 5, which gives me 5 times 100 is 500. So what is my whole if 60% of it is 30? Well, my whole is going to be that 500. 60% of 500 is 300. I'm just going to do it on this way as well. So let's check. My percent is 60, so I'm just filling this in. This comes straight from here. Equals, I don't know the whole, so I'm just going to put a question mark, or better yet, I can use a variable since I don't know it. But I do know its part. My part is what? 300. So that 300 is going to go in for my part. I'm going to ask myself the same thing. They're equivalent. So how do I get from here to here? Times 5. So what do I need to do to here? Times 5. 5 times 100, that is 500. And we see this answer matches what we got when we used our ratio table. So 60% of 500 is 300. Let's just check and look at that. So now I'm left with my last one. My label should be easy. It's going to be percent. Several ways I know that. One is process of elimination. There's nothing left for me to match up. The other one is I don't see a percent sign like I see one here and here. So that means I must be looking for that percent. So what is 60 out of 300? Well, out of, remember this of refers to a what? A whole. So I know this 300 is my whole, 60 is only a portion or a part. And what am I looking for again? I'm looking for that percent. So let's go work on this one again, one last time. 60 out of what? Out of that 300. So I'm just going to fill in, my part is 60, and I'll just label it just to remind us, part, whole. So 60 is my part, 300, that is that whole, equals, and I'm looking for this guy right here. So that's going to be my variable or unknown. And now I'm going to ask myself, how do I get from one side to the other? How do I get from 300 to 100? Well, I didn't multiply, this time I divided by 3. So I need to do the exact same thing to the numerator. So I'm left with 20 out of 100. And we all know that when I have a fraction, how I change this to a percent. So I just take the numerator and just add that percent sign. Let's just check just to make sure it's the same when I use this ratio table. My part is 60. My whole is 300. How am I going to get this 300 to become 100? Well, look at that. I'm dividing by 3. So I'm going to divide by 3. And I'm left with 20. So look at that. No matter which way I solve it, I'm going to get the exact same answer, and when I check, I'll notice my answer is correct. What is missing right here, though? What is missing is that percent sign. Alright, let's go to our next problem. So how are these problems alike? What was the same in all of these? Well, they're all alike because, look, they all had the same number as part of them. They all had 60s and 300. So that's how they're all the same. And they're all percent problems. They all had to do with a percent. Now, how are they different? Well, that's my bigger, harder question. They're different because some of them I was given, actually all of them, I was only given part of the information. In this one, I was given my percent and my whole, but I was looking for that part. In this problem, I was given that percent and a part, but I was looking for a whole. In this last one, I was given a part and a whole, and I was looking for a percent. So they were different in the information that I started with and the information that I was looking for. Alright, so now we have this problem. Solve the following situations. Use models such as 10 by 10 grids, ratio tables, tape diagrams, or double number line diagrams if you need. So here we're going to start. Aurelia is doing her back-to-school shopping. Calculate all the missing values in the table below, rounding to the nearest penny, and calculate the total amount Aurelia will spend on her outfit after she received the indicated or given discounts. So let's just look at our table before we start solving it. The original price of a shirt was $44. The original price of pants, we don't know. The original price of shoes, we don't know. The original price of a necklace is $20. The sweater's original price, we don't know. What we do know in this bottom row is that pants, we received a discount of $15. It's a 30% discount. So since this is how much we saved, we know it's probably going to cost more than that. Shoes received a $9 discount. Sweater received a $7 discount. So what I'm going to do is I'm just going to open up a new page. I'm going to set up a ratio table. I can use a double number line or tape diagram if I want, but since I used those yesterday, I'm going to use the ratio table more. Parts, wholes. I'm just going to write that little reminder for us over here of how to solve it computationally. Part over whole equals percent over 100. I'm just going to save it just so I can refresh it. Alright, so now let's look. this first one, I'm just going to start with my pants. So I need to check my original price. Well, that is how much I would pay normally for it. That's the whole price that it would normally go for. So normally, my pants would cost what? Normally, my pants would cost $44, and that is my whole. I know my percent. Where do I see that information? Well, I see it right at the top. Percent is 25. So my percent is 25. And what am I looking for? I'm looking for my part, or how much I'm saving. How much I'm saving is only a portion or part of the whole. So I'm looking for that part, or the discount. So I have enough information to start. So let's begin. My part is what? My part is, I don't know. The whole, though, is 44. I don't know the discount, but I know the original price. The percent is 25 out of 100. Now, is there an easy way to get from 100 to 44? No, there's nothing I can multiply by. If I multiply this by 2, I'm at 88. If I multiply by 3, I'm greater than 44. So what I need to do is I need to simplify this fraction first. So what can I divide this left side and the right side by? Well, I can divide them each by 25. Hopefully by now in 6th grade we can see that 25 goes into each. 25 divided by 25 is 1. 100 divided by 25, that's 4. I can think of quarters if I need to. 4 quarters to $1. Now, is there an easy way that I can get from this number, my whole, to this number, my other whole? Well, let's look. What can I multiply 4 by to get 44? That is 11. So what do I need to do to the opposite side? Same thing I do to the right. I have to do to the left. So what is 1 times 11? Well, that is 11. So what is my part? My part is $11. I'm saving $11 if they originally cost 44. Now, let's go to another one that's very similar. My necklace. 10% discount, $20. So I'm going to start. What is my discount? My discount is what? Well, let's refer back. Discount, I don't know again. So that's what I'm going to be looking for. What I do know is the percent. What is the percent? The percent is 10. So I'm going to put 10 down. And my whole is what? The whole is the original price. How much it would normally cost. And I see that whole is $20, how much it would normally cost. So now I'm going to do is I'm going to fill in my information up here. So let's check. My part, I don't know. But my whole, I do know. It's that 20. Equals, so always when I'm working for percents out of 100, my percent is 10. So now let's see if I can figure out how do I get from one side to the other. So how am I going to get from 100 to 200? I'm sorry, 100 to 20. I divide by 5. So what do I need to do here? 10 to this mystery number. Same thing I did right here. I divide by 5. And what do I get? I get $2. I could show you with the ratio table, but hopefully by now you see how they both work. Alright, so how much do I save? I save just $2. Let's check these two before we go on. Look at that, 11 and 2. So I have this part filled out. Now I just have to figure out how do I fill in these mystery boxes. So let's go to pants. So pants, I know its discount. Its discount is 30. So the percent is 30. I don't know this time its original price. So since I don't know its original price, I don't know how much it would normally cost, what its total cost would be. So my whole, or the total, is my mystery part. What I do know is the part. I know its discount. The part that I will save is 15. So now I have enough information to fill it in to my equation up here at the top. So let's check. My part is 15, but I don't know the whole. Equals, I know my percent is 30. Percents are always out of 100. So now I have this easy part. How do I get from this number to that number? Well, I'm dividing by 2. So how do I get from this number to this mystery number? The exact same thing. I'm going to divide by 2. What is 100 divided by 2? Well, that is 50. Let's just check it over here just to be sure. When I'm working with percents, it's always 30 out of 100. So just remember, when I write as a fraction, 30 out of 100, and a fraction is part over whole. So that's where my 30 over 100 comes from. I don't know the whole this time, but I do know my part should equal 15. So is there a way to get from 30 to 15? Yeah, divide by 2. So whatever I do to the left, I must do to the right. Divide by 2. 10 divided, or 100 divided by 2 is 50. Look, our answers match. So pants, if you get a $15 discount and it was 30% off, that means they originally cost $50. Let's go to our next one. Shoes, 15% discount of $9. So my shoes, 15%, $9. This $9, is that my whole or a part or portion of it? This $9 is only a small part of my whole. It's not the entire price that would normally cost. So that is my part. I don't know what my whole is. That whole is the original price, and I don't know that original price. So let's fill in. Part is 9. Whole is an unknown. Equals 15% over 100. Let's check. Do I know how to get from 15 to 9? I don't. There's no number I can multiply or divide 15 by to get 9. So what do I need to do? I need to simplify this and see if I can get to 9 somehow. So let's see, what can I simplify it by? Well, I can divide each by 5. Since it ends in a 5 and a 0, I know it's divisible by 5. So this is going to be 3/20. Now let's check. My part I need to end up with is 9. Can I get from 3 to 9 somehow? Yeah, I can multiply by 3. So what do I need to do to this 20? Whatever I do to the top, I must do to the bottom. So I'm going to multiply by 3. 3 times 20 is what? 60. So the original price, if it's a $9 discount, is $15, or $60 with a 15% discount. Okay, my last one is a sweater. Sweater is a 20% discount. And how much am I saving with that discount? $7. Remember, a discount is only a part of the whole. You're not saving the entire thing, it's only a part. So I'm looking for the original price, or how much it normally is. So let's fill out, we're going to use a ratio table this time. 20 to 100. My percent, I can rewrite as a fraction. 20 out of 100, that's where this comes from, this percent. And I'm trying to end up with what? I'm trying to end up with 7, because that is my part. So I don't know what this is right here. Now, is there a way to go from 20 to 7? No, there's nothing I can divide by. So what I need to do is I need to simplify my ratio and see if I can reach it another way. So what can I divide 20 and 100 by? Well, I can divide each of them by 20. I can divide each of them by 5. There's many numbers I can simplify it by. So I'm just going to do its greatest common factor is that 20. So I'm left with 1. 100 divided by 20 is 5. Now, is there an easy way for me to get from 1 to 7? Yeah, multiply by 7. So what do I have to do to this side? Whatever I do to the left, I must do to the right. 5 times 7 is what? 35. So what is my whole when my part is 7? My whole is 35. So let's check. And look at that. Now we're not done. We're going to do this part on the next page. It says calculate all the missing values. We did that. And then it says calculate the total amount. So what I need to do is what? I first need to figure out what does it mean by total cost? Total cost is how much Aurelia is paying. So what I need to do? I need to add up how much each thing cost. This shirt doesn't cost $11. That's how much I'm saving. The pants don't cost $50. That's what it would originally cost. My shoes originally cost $60. I'm getting a $9 discount. So what does that mean? It means I'm paying $9 less. So let's see if we can attempt to solve these. It's originally $44 and I'm saving $11. So I need to subtract them. So 44 minus 11 is 33. How much is my pants going to cost? Well, it's $50 and I'm saving 15, so I need to subtract them. So it's going to be 35. My shoes, normally they cost what? 60. I'm going to subtract 9. These didn't quite line up, so I'm just going to rewrite it. And it's going to be $51. That's how much I'm paying for them with that discount. 20 minus 2 is 18. 35 minus 7 is 28. Now total cost means what? Total cost means I'm adding them all up. I'm not just buying a shirt, I'm not just buying pants, I'm buying everything. So I need to add all of my numbers up. So I'm adding that 33, 35, 51, 18, and 28. So let's just check really quickly. 33 and 35 is 68. 68, I'm just going to cross out so I know they're done, plus 51 is 119. Cross it out. 119 plus 18 is 137. 137 plus 28 is 165. So how much is it going to cost in total for Aurelia to buy all this? Well, it's going to cost $165 if she wants to get this outfit. Alright, let's go on to this next one. Karina paid $40 for an item after she received a $40 discount. Oops, that's my mistake. I'm sorry, guys. I was going to say she got it free then, after she received an $8 discount. Brenda says this means that the original price of the item was $48. She paid $40 after saving $8. Do you think Brenda is right? How do you think she arrived at this answer? So those are two things. So first, how do you think she arrived at this answer? Well, I know. Brenda found that 20% of 40 is 8. If you're unsure, let's look over here. I have 20%, 8, and 40. Well, what is 20% of 40? Well, let's check. My whole would be 40. My percent is 20 over 100. I'm looking for how much I would save. So here I'm looking for, I can't get from 40 to 100, so I need to simplify this fraction. Going to divide by 20. Now I can easily get from 5 to 8 by multiplying by 8, 1 to this by multiplying by 8. So there is my $8 discount. So Brenda found that 20% of 40 is 8. She then added 8 to the sale price. So here's the price she paid. There's her discount of $8. So she says she has $48 for that original price. Now here's our second part. Do you think Brenda is correct? Why or why not? This math seems pretty good. So what do you think? Is she correct? Well, look at this. Because, oops, I forgot to change this name. Because Karina saved 20%, she paid 80% of the original. So that means that 40 is 80% of the original amount. She saved 20%. However, the original amount, she's paying 80% of that. So that's my percent. 40 is a part of the original. This 40 is not the whole price. That is only a part. If I look back here, this 11 is a part. This is my original, is my whole. When I look at this example, this is what this problem is relating to. It's saying we have a discount. This is how much we paid. We have a discount. This is how much we paid. How much we paid, is that the whole? No, that whole is the original price. So we have to be careful. This is not the whole. The whole is the original price. This is only a part. And guess what? My discount is also a part. So we have to be careful when we're finding parts versus wholes. Brenda's math seemed good. It's just that she mislabeled her part as a whole. So what I need to do is I need to set this up. Now I can solve it back here. This time though I'm going to use my ratio table, just so we see that other method again. 80 is my part over 100 as my whole. Where'd that come from again? Well, a percent as a fraction is 80 parts out of 100. What number am I trying to get it to? I'm trying to get it to this 40 because that is a part. So how do I get from 80 to 40? Divided by 2. How do I get from 100 to this mystery number? Divide by 2. 100 divided by 2 is 50. So how much did it originally cost? It originally cost $50. Again, I can see this computation here. I'm simplifying that I need this 5 to become a 50. And I see I get that 40 each way. Here's a model just in case I need a model to verify. It's broken up into 5 parts. 1, 2, 3, 4, 5. 4 parts are going to be shaded in. Why? Well, because my numerator tells me how many parts I have. And I'll notice 80% matches how much she paid. So that 100% is that original price. And my original price is the number that's right across from 100%, which is at 50. So my answers, check out, it originally cost $50. Alright, so my lesson summary. Percent problems include the part, the whole, and percent. When one of these values is missing, we can use tables, diagrams and models, so that's what we used yesterday, those diagrams and models, to solve for that missing number. So I have to have 2 out of these 3 to be able to solve it. Alright, your exit ticket. Since you guys are on the computer, your exit ticket's already going to be in here. So you don't have to do Socrative. What you're going to do is you're going to solve this problem. Then you're going to solve this problem. Then you have one more problem, which is a Google Doc, just like you did yesterday. When you're done with Google Doc, I want you guys to try the Math Mall on Class Links. Alright, good luck.